Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you are all doing well. Welcome to another video from our channel Easy Chemistry for All. I'm Mr. Muad and today we'll be going to lesson 3 from module 14 inshallah. Before we start, please don't forget to share and subscribe to the channel so that you can receive the videos once they are uploaded. Also, try to share it with your friends on the Telegram group so that more and more students can hopefully benefit from these videos. And let's reach our first 1000 subscribers, inshallah. I believe we can do it, bi'idhnillah. Okay, so we are continuing in our Inspired Chemistry series. This is module 14, lesson 3, Thermochemical Equations. So in the previous video, we were talking about lesson 2, which was enthalpy. We learned about delta H, endothermic, exothermic, what does enthalpy mean, and we also learned about Q, how we can calculate heat in chemical reactions, and the use of the calorimeter, and so on. So you can watch that video if you hadn't done so. Okay. So what are we going to learn in this lesson? So after this lesson, you can write thermochemical equations for chemical reactions and other processes. Describe how energy is lost or gained during changes of state. So for example, if you change from solid to liquid, من صلب لسائل أو من غاز لسائل, and so on. How can we know if energy is lost or gained? All right. And finally, we can calculate the heat absorbed or released in a chemical reaction, okay, which we are going to see in some of the problems, inshallah. All right. So the focus question here is, why do you include energy changes in chemical equations? So you are familiar with normal chemical equations, right? For example, if you have H2 plus O2 gives me H2O. Of course, we need to balance the equation. So this is a normal chemical equation, right? So of course, we need to put the state. For example, if we put the state here, so if these were all gases, then we should put the state. The equation is balanced. Sometimes we are going to say that there is an enthalpy for this reaction in joules. Why would we include the energy? And remember that if delta H is positive, it means it is endothermic. If delta H is negative, it is exothermic. يمتص حرارة endothermic, يفقد حرارة exothermic. So we will include these values for chemical equations so that we can know if the reaction is endothermic or exothermic, right? That will help us understand more about chemical reactions, okay? So these are the new terminologies or keywords which we are going to see during the PowerPoint presentation, okay? Just want to double check the recording is working, okay? All right, so let's revise the word combustion reaction, which we saw in the first lesson. So combustion reaction أو تفاعل الاحتراق, okay, is a chemical reaction that occurs when a substance, usually a fuel أو وقود, reacts with oxygen, releasing energy in the form of heat and light. So you remember this image hopefully from lesson 1, the video on lesson 1, where you have a fuel, okay, or a hydrocarbon plus oxygen. Okay, these are the reactants, المتفاعلات. They will result in carbon dioxide, water, and heat and light. So you will produce heat or release heat. So do you think the combustion reaction is endothermic or exothermic? Of course, it's going to be exothermic. So the delta H for combustion reaction should be positive or negative? It should be negative because it's exothermic لأنها تطلق حرارة. Okay, كل التفاعلات الاحتراق تطلق حرارة فهي بالتالي exothermic. All right, and the delta H is going to be negative. All right. So this is again a revision on delta H. As I was saying, if it's going to be exothermic if heat is released outside of the system, and endothermic if heat is going inside to the system. Delta H is negative exothermic, and positive if it is endothermic. All right. Okay. So now writing thermochemical equation. So in grade 10 advanced, we learned about chemical equations, right? Now we added the word thermo. So thermo means you need to include delta H. So what is a thermochemical equation? It's a balanced chemical equation that includes the physical states of all reactants. Physical states يعني الحالة الفيزيائية يعني غاز صلب أو سائل, gas, solid, liquid, of all reactants and products, and the energy change and the delta H. Okay? The energy change is usually expressed as the change in enthalpy, which is delta H, which we studied in lesson 2. So for example, here's a combustion reaction. This is a balanced chemical equation. Look, we have the numbers. So the number of atoms in the left is equal to the right. We have the gas states, right? We have the balanced reactants and products, and we also have the delta H. So balanced chemical equation includes physical states and energy change. All of these will make a thermochemical equation. Okay? So is this equation endothermic, chemical reaction endothermic or exothermic? So because there is negative, it means it's exothermic. Okay? So these are other examples of thermochemical equations where you write the equation, you include the states, and you write the delta H. Okay, same here. We saw these examples in lesson 2 in the video of enthalpy. These examples were in lesson 2 from the video of enthalpy. So if you see kilojoule, it means it's equal to 1000 joules. Okay, لأن من kilo. All right, from the prefix kilo. Okay. So, which of the following is or are included in a thermochemical equation? أي مما يلي تحتويه المعادلة الحرارية الكيميائية. So, physical states of reactants and products, yes. Balanced chemical equation, yes. Change in enthalpy, yes. So, it's going to be all of the above. So, all of these are included in a thermochemical equation, guys, okay? All right. Now, we are going to go and focus on combustion reactions, تفاعلات الاحتراق, and we are going to learn about the enthalpy or heat of combustion. So, heat of combustion or delta H comb from the word combustion of a substance is the enthalpy change for the complete burning of 1 mole of substance. So, what does that mean? So, delta H combustion is actually the delta H for a combustion reaction. الطاقة الحرارية اللي يطلقها تفاعل احتراق. Now, there are conditions. The condition is that 1 mole of a substance. What does this mean? If you look here, this is a combustion reaction. Combustion, okay? This is a combustion reaction. In a combustion reaction, we always have oxygen. So this thing here is going to be the substance. So look, what's the number here? It's 1. So this is 1 mole, right? So I am burning 1 mole of glucose. In here, I'm burning 1 mole of glucose, all right? So it means that this delta H is going to be delta H combustion. In other words, it's kilojoule per mole. Why do we put per mole? Because I have only 1 mole of C6H12O6. Okay, so that's the enthalpy or heat of combustion, delta H comb. It's for a reaction or a reaction that is a combustion reaction, and I need to have 1 mole of the substance. Not oxygen, I'm not talking about oxygen, I'm talking about the substance I react with oxygen. Okay. Standard enthalpies of combustion for several substances are given in table 3, and the standard enthalpy changes have the symbol delta H note. So this is table 3, guys. So these are the energies or heat that comes out when you burn 1 mole of these substances. If you burn 1 mole of sugar, then the amount of energy you will get is minus 5,644 kilojoule. If you burn glucose, all of you know glucose, right? You will get minus 2,808. If you burn methane, تعرفون الميثان صح؟ اللي هو غاز الاشتعال CH4. If you burn it, like on the stove, then you are going to get 891 kilojoule. Why is it minus? Because combustion is exothermic, يطلق حرارة. That's why it's in minus. معناها أن الحرارة بتطلع. Okay? And kilojoule per mole, it means that if you have 1 mole, this is what you will get. If you have 2 mole, you need to multiply 2 by this to know how much you have. For example, if you have 2 mole of CH4, then the amount of energy is going to be equal to 2 times minus 891. Because these values are only for 1 mole, اللي هو تعريف delta H combustion. Now you will see that there is a circle here, right? Or note. What does it mean? What does this note mean? So the symbol or the superscript note means standard state conditions. يعني التفاعلات هاي أو تفاعلات الاحتراق حصلت في درجة حرارة 25 degrees Celsius and the pressure was 1 atm. In other words, if we change the temperature, if the temperature was not 25 degrees Celsius, هاي القيم راح تتغير في الجداول. يعني هاي القيم في الجداول تم حسابها في درجة حرارة 25 وضغط 1 atm. Okay? Alright. So you can stop the video here, try to answer this question and come back. So standard enthalpy changes have the symbol delta H note. What component of the symbol indicates? So this is the symbol, okay? Comes standard enthalpy. So standard is this note. Which symbol indicates that the changes were determined with all reactants and products at standard condition, 25 degrees Celsius and 1 atm. This is what we talked about. It's the note subscript. So when you see this, it means it's standard conditions. Okay. All right, now let's go and focus on changes of state. So changes of state. What does change of state mean? It means that you can change from liquid to solid, solid to gas, gas to solid, and so on. للتغير في الحالة الفيزيائية. Of course, when we change state, we are going to lose or gain energy or heat, right? Because we are changing, we are destroying, or not destroying, we are actually breaking down intermolecular forces between atoms, okay? So let's go to another definition now, which is called molar enthalpy of fusion. So you will notice that we have enthalpy of combustion, معناها delta H حق تفاعل الاحتراق, delta H combustion. Now, if we have enthalpy of fusion اللي هي الذوبان, it means it's the heat that we get from going from solid to liquid. So what's the definition? So delta H fusion means melting, okay? اللي هو الذوبان is the heat required to melt 1 mole of a solid. So if you have 1 mole of a solid, 1 mole من مادة صلبة, and you give it delta H and it became liquid, يعني ذابت, we call this delta H molar enthalpy of fusion or delta H fusion, okay? اللي هي من الصلب إلى السائل. And these are standard enthalpies of fusion, as you can see here. We'll talk about vaporization now, but let's focus on fusion here. For these substances, لهاي المواد اللي عندها هاي الفورمولاز. Okay? So, what is the delta H node fusion for ethanol? So let's look at ethanol. Let's keep going. Delta H fusion is going to be 4.9 4.94 kilojoule per mole. What does this value mean? شو معنى هذا الرقم? It means that you need 4.94 kilojoules, okay, of energy or heat to melt عشان تذوب 1 mole of ethanol. هذا معنى الدلتا H not fusion. So these are the amounts of energy. هاي كمية الطاقة الحرارية اللي نحتاجها عشان نذوب مول واحد من هاي المواد. طبعا كل مادة تحتاج كمية طاقة مختلفة. Okay? So this is the meaning of delta H not fusion. And the word molar because it's for 1 mole. Okay? Because it's for 1 mole. That's why we have molar here. Now let's look at the molar enthalpy of vaporization. نفس المعنى لكن هني التبخر مش الذوبان. So vaporization is the heat required to vaporize 1 mole of a liquid. So means liquid أو السائل will become gas. From liquid to gas. من سائل إلى غاز. Alright? And notice one thing. Of course, delta H vaporization is here now because we are talking about vaporization, right? Now, what is the delta H vaporization for ethanol? Again, look here, ethanol, it's going to be 38.6 kilojoule per mole. What does that mean? It means you need 38.6 kilojoules of heat or energy. نحتاج كمية مقدارها 38.6 كيلو من الطاقة الحرارية to evaporate 1 mole of ethanol عشان نذوب مول واحد من الإيثانول. If I have 2 mole of ethanol, then you need 2 times 38.6, okay, of energy. And notice that delta H naught fusion and delta H naught vaporization قيمهم are positive بالpositive. لاحظتوا؟ كل قيمهم بالpositive. Why? Because you need to absorb energy to change from solid to gas or liquid, from solid to liquid or liquid to gas. لأن عشان تغير حالتك الفيزيائية من الصلب للسائل المادة لازم تكتسب طاقة حرارية. يعني الثلج لازم نعطيه طاقة حرارية عشان يذوب. So it's endothermic لأنه يمتص الطاقة الحرارية. Okay? That's why delta H naught fusion and vaporizations are positive. Right? Now, we also have other things. Okay? We have condensation اللي هو التكثف and that's gas to liquid اللي هي عكس مين؟ عكس vaporization. And we have freezing, okay, or solidification اللي هي التجمد اللي هي من liquid to solid اللي هي عكس الذوبان. So now let's look at water here, guys. Can you see water here? It's liquid, right? So if I want to change the water from liquid to gas, I need to add 40.7 kilojoule. That's the delta H of vaporization. لازم إنه المي تمتص هاي الكمية من الطاقة عشان تصير غاز. الحين if water was gas إذا المية غاز ونريد نحولها liquid نريد نحولها سائل, so it needs to lose the same amount. But the minus here means it will lose heat. And the delta H is called condensation اللي هي التكثف اللي هي عكس التبخر. Same thing here. If you have a solid water like ice and you want to melt it down, you will give it energy. So delta H fusion بالpositive. If you have water in liquid and you want to freeze it, then water should lose energy. And that's why you have the minus here. So same value but different sign. عشان تقول لك أي واحدة endothermic أي واحدة exothermic. Okay? So the delta H vaporization is equal to minus delta H condensation, and the delta H fusion is equal to minus delta H solidification. هذه معناها التجمد وهذه معناها التكثف. Okay? And this is what you have here. These are the phase changes for water. الطاقة الحرارية المصاحبة لتغير حالات المي من from gas, liquid, and solid. Okay. Okay. So now let's go and look at a problem where we can use what we learned and apply it in a real problem, okay? So imagine that there is a bomb calorimeter. This was in lesson 2. So a bomb calorimeter is useful for measuring energy released in combustion reactions. The reaction is carried out in a constant volume bomb with a high pressure of oxygen. How much heat is evolved, يعني تتكون, when 54 grams of glucose is burned according to this equation? So they are asking you if you burn 54 grams of glucose, how much energy will be produced. لو حرقنا 54 جرام من الجلوكوز كم كمية الطاقة الحرارية اللي بتتكون. And you know the equation, you know this equation, and you know delta H combustion. This is for 1 mole. Okay? So, if it were me, then I would say, okay, I know that the equation is balanced. I know that 1 mole is going to give me 2808 كيلو جول. طبعا الماينس هاي بس تقول لكم ان هي اكسوثيرميك، يعني الطاقة الحرارية تفقد او تتكون لا تمتص. اوكي، هذا بس معنى الماينس، هذا معنى الماينس. اوكي، so I know that 1 mole is going to give me 2808 kilojoule. Now if I burn 54 grams, how much will I get? هني ما أقدر أسوي الضرب التقاطعي. I cannot do cross multiplication to get my answer because I need to change grams into moles first. Okay, I need to change grams into moles first. So this is what we know. We know the mass of glucose, 54 grams, and we know the delta H combustion, which is for 1 mole. المول واحد. What we don't know is Q, كمية الطاقة الحرارية اللي بتتكون. Okay? So basically what would I do here is that first we need to change 54 grams into moles. Now we know that moles من صف عاشر, moles equals mass divided by molar mass, right? Now if you go to the molar mass, or let's just write it here, the molar mass of C6H12O6 is equal to 180 gram per mole. طبعا هاي القيم غالبية الأحيان تعطاكم في الامتحان ولازم تستخدمونها. Okay, so you know that the mass here is 54 grams over 180 gram per mole. So when you do that, the answer that you are going to get is 0.3 mole C6H12O6. So now I can do the following. I know that 1 mole is going to give me 2808 kilojoule من الطاقة. Now ال 54 جرام كم فيها من مول؟ فيها 0.3. فالحين أقدر أستخدم هني 0.3. So 0.3 mole is going to give me how much? So I will change that here. I will multiply and then divide. الضرب التقاطعي, cross multiplication. So I will do 0.3 times 2808 over 1. And it will be 842.4 kilojoule. So if you burn 54 grams of glucose, إذا حرقنا 54 جرام الجلوكوز, هاي كمية الطاقة الحرارية اللي بتتكون. طبعا الناتج ممكن يكون هيك, وإذا حطينا الماينس ما في مشكلة. ليش؟ لأنه الماينس يقول لنا فقط إن هي اكسوثيرميك. ما يغير في الرقم بس يقول إن هي exothermic. Okay. Now you can stop the video and look at the solution here. All right. Some of you might say, Mister, where did we get the molar mass from? If they didn't give it to you in the exam, then you can get it from the molar masses of each element. The molar mass of carbon 12, oxygen 16, ال H1. فكم عندنا احنا من كربون؟ عندنا 6 صح؟ So 6 times 12 plus كم هيدروجين عندنا؟ واحدة 12. So 12 times 1 plus كم أكسجين عندنا؟ عندنا 6. So 6 times 16. That's why we get 180. Okay. So we did this. Okay. So we need to change the grams into moles. All right. By dividing mass over molar mass, then we get our answer, and then we do the cross multiplication. So the delta H اللي أو الQ كمية الطاقة الحرارية اللي بتتكون is going to be 842 kilojoules. All right. Okay. Calculate the heat required to melt 25.7 gram of solid methanol at its melting point. Use table 4. Okay. Go back to table 4. This is table 4. Okay. Methanol and melt down. They said melt down يعني الذوبان. So we'll be talking about delta H fusion. So it's 3.22 kilojoule. Okay. يعني what's the reaction going to be? The reaction is going to be CH3OH. الميثانول رمزه CH3OH. Solid will become CH3OH liquid. هذا هو التفاعل من السوليد للليكويد. and delta H fusion equals 3.22 كيلو لاحظوا انه هني بالبوزيتيف. ليش؟ لانها تمتص الطاقة الحرارية. اوكي. Let's just double check. Yes, 3.22 methanol delta H fusion هي الذوبان. Okay, let's go back here. Right. Okay. So why do we say kilojoule per mole? Because I have 1 mole here. Okay. So it's not 2 moles or anything. Okay. Now it's the same thing. So what we know, so the known, we know the mass of methanol, which is 25.7 grams. We know the delta H fusion, which is equal to 3.22 kilojoule. Okay. So what we don't know, or the unknown, is the Q produced. So the first thing that we need to do, again, you know that 1 mole is going to give you 3.2, or you need 3.22 kilojoules to melt down 1 mole of methanol. If I have 25.7 grams, how much do you need? So first, we need to change grams into moles, صح? So moles equals mass over molar mass. طبعا ال CH3OH المولر ماس تبعتها بتكون 12 زائد 4 زائد 16 اللي هي تساوي 32 gram per mole. You will tell me, Mister, how did you do that? I will show you quickly. CH3OH. So it has 1 carbon, 4H, 1 oxygen, صح؟ H3 و H4, 1 carbon and 1 oxygen. This is from your grade 10. هذا من الصف العاشر. هذه المولر masses حق كل ذرة. Okay? So what do? You do 1 times 12. Because you have 1 carbon, so 1 times 12 plus. How many H's do you have? 4. So 4 times 1 plus. How many oxygens do you have? 1. So 1 times 16, which is equal to 12 plus 4 plus 16 equals to 32 grams per mole. Okay? So this is going to be 25.7 divided by 32, which is equal to 25.7 divided by 32. That gives you 0.803 mole. So all you need to do now to find Q is multiply 0.803 times 3.22 kilojoule. Okay? And that is going to give you 2.586 kilojoule. So what does this mean? So this means if you burn إذا حرقنا 25.7 إذا ذوبنا 25.7 جرام من الميثانول، كمية الطاقة الحرارية اللي نحتاجها عشان نذوب هاي الكمية تساوي 2.586 كيلو جول. Okay, that's it. You can rewatch this part or the previous part if you want to know. If you did not understand or if you need some parts which were difficult a bit. أهم شيء إنه إذا عطانا الجرامز لازم نحولها لمول وبعدين نضرب في الدلتا اتش. إذا عطانا المولز على طول، كمية المولز هاي نضربها على طول في الدلتا اتش بتعطينا الناتج. Okay, so you can try this on your own. Okay, same thing. You have NH3 ammonia. You have the mass. Delta H condensation. So ammonia condensation اللي هي تساوي minus delta H vaporization. يعني لما نتكلم على condensation يعني احنا قاعد نتكلم على هني. So it's going to be 23.3. Okay, but condensation is going to be in minus 23.3 لأنها تساوي، لأن دائما معكوساتهم إذا هاي positive هاي المفروض تكون negative. Okay, it's kilojoule per mole. Yeah, and the molar mass, الMM هي molar mass of ammonia NH3 is going to be 14 plus 3, so 17 gram per mole. Okay, going to be 17 gram per mole. Okay, now the last part of this PowerPoint presentation, talking about combustion reactions. So combustion is the reaction of a fuel with oxygen اللي احنا نعرفها already. Okay, plus oxygen gives me CO2 plus H2O plus heat. طبعا الX والY معناهم أي أرقام ممكن يكونوا تحت. Okay, so food is the fuel in combustion reactions in biological systems. So when we eat glucose and we burn it, then that gives us energy. Okay, gives us H2O plus CO2 plus energy اللي هي درستوها في الأحياء أظن glycolysis. Okay, you burn glucose, okay, or other fats or something اللي هي الفيول with oxygen, and that would give us energy or ATP if you remember. Okay, this energy is stored in ATP. So this is an example of this equation. Now, a very important thing that I want to show you. Look here at this equation. This thing here, you can write it also like this. So what's the difference between this and this? The difference is إذا شفنا إنه كمية الطاقة موجودة في البرودكتس كأنها عبارة عن ناتج من النواتج. It means it is exothermic لأنها تكونت في النواتج. So it's in the product side. So we can write it like this, or we can show the delta H as a minus. Okay? If For example, you have A plus B plus 100 kilojoule gives me C. Then actually we can write this as A plus B gives me C, and then delta H equals positive 100 kilojoule. إذا شفنا إنه الرقم أو الطاقة الحرارية موجودة في المتفاعلات, if we see that the energy is in the reactant, it means it's absorbing, يعني بتمتص هاي الطاقة الحرارية عشان تكون لي البرودكت. So the delta H is positive. If we see the energy or the heat in the products, يعني في النواتج, معناها إنه هاي الطاقة تكونت, معناها إنه تفاعل إكسوثيرميك كون حرارة, أطلق حرارة. So that's why the delta H is negative. So we can write it in both ways, okay? If you see it in the exam, these two are the same and these two are the same, right? So, which of the following has a positive change in enthalpy? So which one has delta H positive? Is it combustion, vaporization, condensing, or freezing? So combustion احنا نعرف انه delta H negative لانها تكون لي حرارة, تطلق حرارة. Vaporization اللي هي التبخر, we know that delta H is positive in table 4 if you remember. Condensation, we know that delta H is negative لأن هي عكس ال vaporization. Freezing, we know that the delta H is negative لأن هي عكس الفيوجن, عكس الذوبان. عشان نتجمد لازم نفقد حرارة. Okay, so the correct answer is going to be vaporization. Alright? Which of the following is true for enthalpy of combustion? It is positive for glucose? Wrong. It's always negative. It's negative for propane? Yes. It measures the change in temperature that occurs? No, it does not measure that. None of the above, no, because we know that it is negative for propane. The delta H تكون negative of combustion. The enthalpy of combustion دائما negative يا طلاب, okay? So, yeah, pay attention to that. Alright, it seems that we reached the ending of our lesson. So, after this lesson, what you learned, hopefully, is that how you can now write thermochemical equations. You can describe if energy is lost or gained in a chemical change, or a physical change, من solid to liquid, liquid to gas, and so on. And you learned how to calculate the heat absorbed or released in a chemical reaction, the Q, اللي هي حلينا عليها مسائل. Okay? So thank you very much for watching this video. I hope it was helpful. Again, if you have any comments or questions, please contact me or use the comments section below the video. I wish you all the best بإذن الله. Take care and see you in the next video. Bye bye. Inshallah.